Welcome everyone to this session. My name is Dominic Yaki. I'm an engineer in the AEM Screens team. With me today are my dear colleagues Tobias Reis and Damian Antipa. They will be answering any questions you may have in the chat. So please don't hesitate to ask your questions in the session chat during the presentation. Today, we will be talking about AEM Screens, why and how we made the journey to the cloud. Let's first look at why. AEM Screens is a digital signage product. I will tell you more about what that means in a moment. Since its inception, AEM Screens was embedded as an add-on in Adobe Experience Manager. In time, Adobe Experience Manager, by its very nature as a content management system, created considerable challenges for the operation and expansion of AEM Screens. This mattered because those challenges inhibited the expansion of AEM Screens in terms of scaling, delivery speed of new features, and team efficiency. So how could we scale to 1 million digital devices, digital signage devices, instead of only 10,000? How could we support UX and data flows optimized for digital signage? How could we focus on feature development and fast delivery to the customer? The journey to the cloud allowed overcoming these challenges and resulted in an architecture that scales well for the needs of digital signage, while reducing future development and operational costs quite considerably. I hope that this small case study will motivate you to strive for expanding the horizon of products and projects you work on in your daily lives. Okay, now let's first look at what digital signage actually is. In essence, digital signage means bringing digital experiences to physical spaces. Digital signs use hardware, such as various types of screens and projection, to display content. The content can be anything from information, video, images, to interactive experiences. Digital signs can be found in public spaces, transportation systems, museums, stores, hotels, restaurants, corporate buildings, you name it. This in order to provide things like wayfinding, marketing, shopping interfaces, and advertising. So in addition, the hardware supporting digital signage can be equipped with input devices such as cameras, touch displays, beacons, and much more. This allows content to be adjusted based on user input or recognition of user segments. As you can see in this picture, a screen with a camera could be used to recognize approaching customers, then identifying basic characteristics such as age and gender, and subsequently displaying personalized content, such as the men's suit you see right here on the screen. Interactive experiences like these is where the true power of digital signage resides. Now, what are the components AEM Screens implements digital signage with? Firstly, we have a platform application called Screens Player application. It runs on the customer hardware devices located in the aforementioned physical spaces. Its job is to play the assigned web-based content at a prescribed schedule and sequence, as well as passing user interactions to the web application representing that content. And secondly, we have a so-called player management. Player management is an administration console where content and scheduling rules can be assigned to individual players. The player manager can also send commands to and receive telemetry from the player. The player management console displays player status information, for example, whether it is currently offline or online. Thirdly, we have AEM sites to enable content authors to create and manage content based on AEM Screens optimized templates and components. As you can kind of see, two of the three pillars of AEM Screens, the player and player management, represent concepts that are entirely outside of what one would consider content management. Naturally, AEM Screens having been an add-on in AEM Sites, a content management system, this created challenges. Let me give you some examples of such challenges. First and foremost, I guess content management is predicated on unidirectional content delivery. This means content authors create, edit, and stage content on an authoring instance, then publish the content to one or more publish instances. There is almost never a reverse flow of data from the publish to the authoring instances. Digital signage, however, relies on bidirectional communication with its player applications, with a heavy slant towards receiving data from players as what we call telemetry. In player management, we need to see player status. Is it online or offline? What were its last actions? Did it execute a command we sent? Did it download its content and how often, etc.? So furthermore, the player management is basically a zero configuration business. Players of any customer are always treated the same and go through the same player life cycles, requiring no customer-specific configuration in essence. In contrast, to support AEM Screens, deployments of Adobe Experience Manager required heavy customizing of the already complex configuration of AEM, often resulting in configuration conflicts between content management or digital signage concerns. Lastly, due to the bidirectional nature of digital signage, scaling by adding more and more Adobe Experience Manager instances as the player base grew became ineffective and costly through over or under provisioning. So looking at those challenges, the team set out to find a path forward, and we defined some high-level key requirements. We recognized that player telemetry required an architecture optimized for writing. That is, the ability to receive and process continuous telemetry input at scale. Also, with AEM Screens being a young and upcoming product, we needed an architecture that scales elastically with the growing of customers and therefore players. Finally, we wanted an architecture that is loosely coupled. We wanted to break down the individual components of AEM Screens in a way that would minimize dependencies between functional areas of the product. This would allow us to reap lots of benefits, like flexibility in choosing optimized and modern technology for the right job, down to a very granular level, or things like having a reduced blast radius where failure of a particular service doesn't take down the whole system. Most importantly, however, it would allow us to accelerate the delivery speed of new features with things like fully automated continuous integration and rapid deployment, end-to-end testing, and things like that. So if we look at some of those key requirements like scaling and elasticity, write-heavy data flows, and loose coupling, it kind of comes at no surprise that the team considered an event-based architecture early on. Just as a quick reminder, event-based means when your application changes the state of something, it will send a notification, an event, about this happening, with the event payload describing the detail of the change. That part of your application that created the event sends it off via a so-called producer to a specific topic hosted on a message broker, or event bus, as we call it. And after having done so, no longer cares. It doesn't care whether this event will ever be consumed by anything or who will consume it, and therefore it is kind of entirely asynchronous. Other parts of your application can now subscribe to and consume such events from the topics available on the event broker at a time of their choosing. They have no idea where, how, and by whom the event was produced. You're fully decoupled from the producers. All we need to know is included in the event payload, and a consumer can execute a specific piece of business logic on it. So the decoupling between producers and consumers also means we can easily scale any one of them independently. So using an event broker therefore checked a lot of boxes of the key requirements we identified. Now we took it even one step further. Traditionally, the current application state is stored directly in a database or similar form of persistence. If we look at a current application state as a series of events that led up to that state, we can always derive the state of an application by replaying those events. We can use this to represent all our domain entities in the application, such as our players, for example. The current state of a player could be expressed as the following state-changing events. A player was created, then its name was changed, later it got certain content assigned, and a year later it was maybe deleted. But why would we do such a crazy thing? The main benefit, a potential business value goldmine, so to speak, is to enable experience intelligence. By knowing where we are, but also how we got there, we can analyze the past and recognize patterns. Those patterns can then be transformed into new product features or serve for protecting users, for example. Let me give you some examples. So, for example, by knowing the steps a user took to perform certain tasks based on the real-world events received, we can analyze their efficiency and then streamline and simplify them, resulting in a reduced number of clicks in the UI, for example. Another example would be to develop preventative actions. For example, after recognizing which events happened before the screen of a customer device suddenly went blank with no content to play. Another benefit of event sourcing is that it plays very well with the pattern called command query responsibility segregation. CQRS provides for separation of read and write operations, allowing you to optimize and scale each independently. Let's again take the player telemetry as an example. On the command side, that is the right side, the telemetry coming in at scale is processed by very small functions, sending off events to the telemetry events topic. On the query side, that is the read side, we have multiple consumers. One of them updates as a fast Redis cache for fast player status consumption by the user interface, while another consumer forwards data to destinations like monitoring and logging tools. Let's now have a look at how we built our cloud architecture with event-based operations at its core. First, we established our event bus at the center, featuring event topics covering all our domain entities, such as the player entity, as well as event topics, serving in a more traditional message broker role. The event bus is fed with events by those parts of our application that produce state changes. For example, the part that creates a player record when a player is added, or the part that receives telemetry again from a running screens player and transforms the incoming data into a series of events. Depending on the nature of the data, the event broker will remember those events forever. For example, for the main entities, such as the player, while other topics only hold events for mere hours or days, depending on the use case. Now, of course, we also want to do something with the data available in the event bus. So our application features a set of event consumers that take those events and transform them into various output formats, into what we call projections or materialized views, each optimized for a specific use case. For example, our player management UI wants to have fast access to the list of current players for display. For that purpose, one of the consumers continuously updates the current state of players in a Redis cache based on the events it receives. We also have situations where the same event topic is projected into multiple materialized views. Take the telemetry again, for example. Parts of the telemetry are displayed in the player management UI as the online status of players. We therefore project that subset of the events data into Redis again. Other parts of the same telemetry are of interest to support staff and engineering and are projected into a Splunk log collector. Still, other parts are of interest for monitoring, graphing, alerting, stuff like that. And we are working right now on projecting those into things like Elasticsearch. And finally, we have the public HTTP API that allows the Screens players and the player management UI to access AEM Screens Cloud and to take part in both the command and query sides of the application, creating state change events via the producers and reading information from projections. As a side note, AEM Screens Cloud does not handle anything related to downloading of the actual content or the content production. For this purpose, we have the players talk directly to Adobe Experience Manager, where the content management part is handled. All right, let's have a quick look at some of the products we use for the architecture. For the event bus, we use the well-known Apache Kafka, which is an open source distributed event streaming platform. For us, it is kind of the digital equivalent of the human body's central nervous system. It is the technological foundation for the continuous flow and interpretation of data, so that the right information is at the right place at the right time. For any application concerns that require long-running processes, we use Adobe's internal container as a service platform, the Kubernetes-based Adobe Ethos. We use it to deploy Node.js containers that run our event consumers responsible for projecting events into materialized views as described previously. It features fully automated continuous integration and deployment. As most of Adobe's internal services, it is fully integrated in the Adobe ecosystem, and deployments benefit from APIs and services to access other Adobe solutions with relative ease. For our short-running application concerns, we rely fully on functions as a service or serverless on the Adobe I/O runtime platform. The entirety of our public HTTP API, as well as all the state changing or event producing parts of our applications, are implemented as a granular set of functions using Node.js-based OpenWhisk actions. The actions are also used to read from our Redis cache and provide fast JSON output to our player management UI. Also, our Screens player sends its telemetry via our HTTP API, where Adobe I/O runtime actions transform the telemetry to events. Finally, Adobe I/O runtime is fully integrated with our CI/CD. It takes us about 5 minutes to push a production change through all environments. Last but definitely not least, we have our player management UI. It is state-of-the-art, built on React.js and fully implemented with the Adobe Spectrum design system. We have spent considerable effort with our digital experience design team to ensure flows that are optimized for digital signage. The UI is fully integrated with the Adobe Experience Cloud, making transitions between the various solutions seamless and transparent for the user. In technical terms, the UI is packaged and deployed on Project Firefly, which is Adobe I/O's cloud-native application framework running serverless. So let's conclude this presentation with what we have learned. We recognize challenges arising from conflicts between the paradigms of content management and digital signage. We found those challenges mainly expressing themselves in the areas of read versus write optimization, scaling with the growing number of players, as well as the tight coupling to content management concerns, such as configuration issues and tech stack limitations. We developed ways and means to help overcoming those challenges. We applied the principles of event streaming and command query responsibility segregation to enable us to process incoming data at scale, while independently optimizing read and write concerns. We enabled elasticity by enabling separate parts of our application to scale independently down to the function level. And finally, we strive for a decoupled or loosely coupled system, reducing dependencies and blast radius through an event-based architecture and functional decomposition. So I hope this journey will inspire some of you and your projects, and I thank you for your attention. So now let's see whether we have any questions left over from the chat. Toby?
Thank you very much, Dominic. There are no questions yet.
Okay.
We weren't answered already.
No problem, it's late over here, so.
And it's the last session.
Yes. Yeah, I see one. First time hearing about Ethos. This is an internal only project. Yes, this is Adobe Ethos is internal only for the time being. I do not know what the plans are to make it public or not, but a lot of other Adobe services, such as Adobe IO Runtime, rely entirely on Ethos. So, yeah.
Yeah, we could summarize it's a multi-cloud container platform with self-service provisioning, pipelines, tooling, compliance, and security controls.
Yeah.
Go
ahead, Toby.
Well, you can read it, obviously. So
yeah.
So there's a question about when will this be available?
Well, I think the very good news is this is already available.
Yes.
So please come to us. We need customers. Yeah. So anyone that has Adobe Experience Manager deployment in the cloud, so AEM as a cloud service, can totally onboard with us and use screens on the cloud as well.
So there's the next question about the transition, or actually two questions about transition and migration to the cloud.
Mm-hmm.
Yeah.
Yeah, so we do have tools to migrate the screens content that is, let's say, player management related and device information to the cloud. From the perspective of AEM components templates, you might even know more about that, Toby. I'm not sure a lot of migration is required there, right?
Yeah, so content is basically the same. This is mostly about the player management that was presented now, and players. So the software that runs on the digital signage device is actually agnostic to to either cloud or classic.
Yeah. Yeah, I see a question here. Is it required for assets to be located in the AEM as a cloud service platform, or would this new Screens cloud service work with an on-premise AEM installation? So yes, the Screens as a cloud service is basically agnostic to whether AEM runs on AMS or as a cloud service or even on-premise. We have not yet fully tested cooperation with on-premise, but there's no reason that it should not work with it.
Let's say it's on our roadmap, basically.
Absolutely, it is. All right. Any more questions?
So I pasted 2 links to the chatbot. One is the link to the forum where we can continue the conversation, and the other one is to get an idea about more digital signage use cases that we already cover with AEM Screens.
Yeah, that's your question here, again from Ted. If I'm understanding things correctly here, nearly all of the AEM Screens cloud service product now entirely takes place outside of AEM runtime, of an AEM runtime itself, with only the uploading and management of assets. Well, that's basically true, yes. The player management, or device management as it's still called in the tools itself, is now entirely outside of an AEM container, and basically a multi-tenant cloud service for all Screens customers that have their content management also on the cloud, or on-premise, or AMS. So yes.
Nevertheless, it's a unified experience, content management and player management.
Yes. It's basically more an under the hood separation of things than conceptually.
Yeah, at least with AEM as a cloud service.
Yeah.
Yeah.
Question from Lingesh. Customer who wants to use Screens as a cloud service, do they also need AEM as a cloud service? So no, as we've said, Screens Cloud supports basically all 3 modes of an AEM deployment, which is either cloud service as a cloud service on AMS, Adobe Managed Services, or on-prem, the last of which is not fully tested yet, but on the roadmap.
Yeah, preferred is probably managed. So managed on our side.
All right, then thanks again for your attention and all the best. This concludes the session.